Lesson 2 of Chapter 4 is on properties of divisions. We were going to talk about dividing polynomials. Before we do this, I typically like to review dividing just numbers. So if we were to take and divide 1,315 by 23, how we'd set that up is we'd put 23 on the outside, on the inside is 1,315. So the 23 is called the divisor, the 1,315 is called the divisor, the 23 is called the dividend. How many times does 23 go into 13? None. How many times does 23 go into 131? That would be 5 times. We now take 5 times the 23 and that gives us 115. Subtract these and we get 16. Bring down the 5. How many times does 23 go into 165? That'd be 7 times. Take 7 times 23 and that gives us 161. Subtract those, we get a remainder of 4. Now, back in like 4th, 5th grade, when you got remainders, the first thing you did is you just wrote remainder 4. Then after improving on that skill for a little bit, then you'd take the 57 and the remainder of 4, and you'd say 57 and 4 over 23. We're going to use that aspect as we divide these polynomials. So, you're going to be asked to divide two polynomials, so when we set it up, now our dividend, x to the 4th minus 16, it's missing some terms. So I'm going to put in those missing terms with a 0x to the 3rd, a 0x squared, a 0x, and a minus 16. That'll allow us to have columns to work underneath. Okay, what times x squared gives us x to the 4th? That would be x squared. Now we take that x squared, take it times the divisor, and we get x to the 4th plus 3x to the 3rd plus x squared. Now we draw a line and we subtract. Now you'll notice when I subtract I put parentheses around it, so we subtract each of these terms. So x to the 4th minus x to the 4th just cancels out. 0x to the 3rd minus 3x to the 3rd gives you negative 3x to the 3rd. 0x squared minus 1x squared gives you negative 1x squared. Bring down the next term. Do it again. What times x squared gives us negative 3x to the 3rd? That would be a negative 3x. Take the negative 3x times the divisor, and we get negative 3x to the 3rd minus 9x squared minus 3x. Draw a line and subtract. And the first terms cancel. We end up getting negative 1x squared plus 9, which is 8x squared. 0 minus a negative 3 is equal to 3x. Bring down the minus 16 and we do it one more time. What times x squared gives us 8x squared? That would be 8. Multiply 8 by the divisor and we get 8x squared plus 24x plus 8. Draw a line, subtract, and we get a negative 21x minus 24. Now, this is going to be our remainder. So, how do we write our answer is the question. Well, here's how we write our answer. This is what you're going to see in the back of the book. We just got done taking x to the 4th minus 16 and dividing by x squared plus 3x minus 1. So here is how you write your answer. There's my quotient. And then I took the remainder, the negative 21x minus 24, and I put it over the divisor. So that's how I want you to answer these problems. Of course, showing your work on the long division. The next thing to talk about is the remainder theorem. The remainder theorem says if a polynomial f of x is divided by x minus c, then the remainder is f of c. So here's how we explain that. Here's a 3rd degree polynomial. If you were to take it and divide it by x minus 2, you can see that work is done right down here. You would end up getting a quotient of x squared minus x minus 1. And you'll notice at the very end, at the bottom, you end up getting a remainder of 3. Well, the remainder theorem says that taking this 3rd degree polynomial and dividing by x minus 2 would be equivalent to just plugging 2 into that function. And if you plug 2 into that function, you'll notice that the result you get is the same as the remainder you get when you divide. So the remainder theorem is helpful and handy for basically just figuring out the remainder and not caring about the quotient. We also have a theorem called the factor theorem. It says a polynomial f of x has a factor of x minus c if and only if f of c equals 0. So this says show that x minus 2 is a factor of this third degree polynomial. Well, if x minus 2 is a factor, we should be able to put 2 into this function and we should get 0. So let's see here, putting in 2, we should get 8 minus 8 plus 6. I think I did that wrong. I did. We get 8 minus 16 plus 6 plus 2. F of 2 equals 0. That confirms that x minus 2 is a factor of f of x. So the next example says use synthetic division, not long division, but synthetic division to find the quotient and the remainder when you take this fourth degree polynomial and you divide by x plus 3. So synthetic division, in case you forgot, you always use the 0 of what you're dividing by. If we're dividing by x plus 3, then I need to have a negative 3 in this box on the side because that's the 0. Now I list the coefficients. 2. 5. I notice that I'm missing an x squared term, so I need to put in a 0 there. Then we got negative 2 and negative 8. Draw a line. First thing we do is drop the first coefficient 2 straight down, so we get 2. Now we take the 2 times the number in the box, negative 3, and put it on the next column. Now we add those. Then we multiply, add, multiply, add, multiply, and add. So the very last number represents your remainder. The other numbers represent the coefficients. So if we take this fourth degree polynomial and we divide by this x plus 3, our answer is going to be 2x to the third minus 1x squared plus 3x minus 11. And we get a remainder of 25, so I say plus 25 over what we're dividing by, x plus 3. And that's how you'd write your synthetic division. Example 3 says find a polynomial with prescribed zeros. This one says find a polynomial function of degree 3 that has zeros at 2, negative 1, and 3. So we'd start off by writing it in a factored form. Since it's got a 0 at 2, we'd write x minus 2. Since it's got a 0 at negative 1, we write x plus 1. And since it's got a 0 at 3, we write x minus 3. Now that's a really good answer, except for we need to put it in standard form. So I begin by foiling the first two factors. And that gives me x squared minus 1x minus 2. Then I FOIL that out to get my standard form equation. X to the third minus 3x squared minus 1x squared minus 2x plus 3x plus 6, and then that could just be simplified. X to the third minus 4x squared plus 1x plus 6. Here's how I could check that answer, you guys. I could take that answer, I could enter it into my graphing calculator and look to see if it crosses at 2, at negative 1, and 3. If it doesn't cross at those places, then I made a mistake someplace in the foiling. So here's the homework problems for lesson 4.2. It is on page 243. This will be collected Wednesday.